This conference will now be recorded.
Hello everyone. Good morning, good afternoon, or good evening. Let us start our today's topic. So, as discussed yesterday, today we are going to enter into the first topic in our Linux environment, which is managing partitions and file systems. So, mostly it's a very big topic. So, first we are going to discuss the theoretical aspect, and then we are going to work with practicals. So most probably in today's class there would be very less practicals and more theory, right? So let me just power on the machine before I forget to do that. Okay, so the topic name, as you see on the screen, managing partitions and file system. The first question over here is, what is a partition? And why do we need to do partitions in a hard disk? See, normally when you have a hard disk, you have an option to keep everything in a single hard drive without any partition. For example, let us say that this is our hard disk. In this hard disk, you can install your operating system. You can keep some applications installed. You can keep some important data. You can keep some backup. Everything you can keep in a single hard drive without any partitioning, right? But if you keep it in a such a way, let us say due to something, if your OS crashes, as soon as your OS crashes, all the data in the hard disk will be affected because there was no partitions. Now, instead of that, suppose if I have made partition, one partition for OS, one partition for applications, one partition for data, one partition for backup. So like that, let us say that I have divided four partition and each partition was holding some important thing. In this scenario, if OS crashes, then you see only OS related partition will be affected. The rest of the other partition and its data would be safe and sound. This is the reason why we prefer going with partition to safeguard your data and moreover to segregate your data, right? Division of your data would be easy. So partitions are nothing but division of your hard drive in order to protect the data inside it and also to segregate the data in an easy way, right? So this is the need of partitioning. We understood that what is a partition and why do we need to make partition. Let us now try to understand that how many partitions can I create in a single hard drive. Now it depends on what scheme or what layout you're following. Basically, there are two styles of partitionings that you can create. There are actually other types also, but these two types are very popular and widely used in Linux environment. MBR style partitioning and GPT style partitioning. MBR stands for Master Boot Record, whereas GPT stands for GUID partition table or guided partition table, whatever you call it. MBR is one of the oldest style of partitioning, right? It was actually introduced by DOS people, MS-DOS people, Microsoft DOS, the command line of Windows operating system. So earlier, initially, before introducing Windows, there used to be MS-DOS, the command line operating system. So MS-DOS people have introduced this concept of MBR partitioning. So sometimes MBR partitioning is also called as DOS-based partitioning. So in MBR, you have three different types of partitions: primary partitions, extended partitions, and logical partitions. Basically, primary partition is that partition that gets activated first during boot. Whenever you power on the machine, the partitions, as soon as the hard disk is activated, the partitions that gets activated first are primary. After that, extended. After that, logical partitions will be activated. So usually, primary partitions are used to store your operating system and operating system related information data. Like during installation, we created three partitions: root, boot, swap. So basically, those root, boot, swap will be storing under primary partitions. Now, if you go with only primary partitions in a hard disk, then there is a limit. The limit is within a hard drive, you cannot go more than four primary partitions. Now, if I go only with four partitions, maybe in future there might be a requirement that I need five partitions to store different data, or maybe eight partitions, or maybe 10 partitions, like that. So I cannot go for all those partitions in that way. So in this scenario, what we do is first three partitions we will go with primary. Let us say that you have 100 GB hard disk. In 100 GB, let us say 10 GB I have given to primary. So 30 GB is gone. That means 70 GB is remaining with me. Now with that 70 GB, I'll create a special partition which is extended. Now extended is a special type of partition that allows you to create more partitions instead of creating only four partitions. So if you go with primary, the limit is only four partition. Even if the space is remaining, you cannot use it. So four partitions, let us say, is not sufficient to me. Maybe I need six partition, 8, 10, 12 partitions like that. So in that scenario, first three partitions we will give to primary. With all the space remaining, we will create extended partition. Now in extended, you can create number of more partitions which will be called as logical partitions, right? So the name extended is given because of that. It extends the capability to create more partitions. If you go with only primary, the limit is 4, but 4 might not be sufficient in an environment. So we go with first three partitions as primary. With all the remaining space, we can create a special partition extended. What is special in extended? Inside extended, you can add many more partitions, and those partitions will be called as logical partitions. So with the help of extended and logical, you can get more number of partitions. You will not be stuck to four partitions. So this is the way how MBR works, right? It works with three partitions: primary, extended, and logical, right? If you only go with primary, the limit is 4. Or else you can go with three primary, one extended. Within a hard disk, you can only create one extended. Inside extended, you can make number of logical partitions. So in that way, you can achieve more number of partitions than only sticking with 4 partitions. Now, what is the total limit of MBR to create partitions? In MBR, maximum you can achieve up to 60 partitions. So you cannot go beyond 16. MBR has a limit of creating only 16 partition per hard disk. And the total hard disk is support is up to 2 TB. So if your hard disk is up to 2 TB and you want to go maximum up to 16 partitions, then you can go with MBR. And that too, how you can achieve 16 partitions? 3 primary, 1 extended, and all the remaining you can create as a logical partition. So this is the limit of MBR. Now, there is one more style of partitioning which is becoming slowly popular. Still, MBR is very famous, but GPT is slowly taking its place in industry. So, if you are working with GPT is very simple and straightforward. It does not have complications of primary extended logicals. Simply the partitions inside it are called as partitions. There is no primary, there is no extended, there is no logical when it comes to GPT. So in GPT, directly you can create partitions up to 128. And the hard disk it support is 2 zettabyte. Now that is a very promising figures. So in a hard disk you can go up till 128 partitions, and the hard disk its support is 2 zettabyte or 2 zebibyte, whatever we call it. Now what is that zettabyte or zebibyte? We'll understand in a short while. So as of now you just understand the differences that MBR goes maximum up to 16 partition with a hard disk not more than 2 TB, whereas GPT will allow you to give 128 partition with a hard disk size it support up to 2 zettabyte or 2 zebibyte, right? And partitions are simple partitions. There is no primary, extended, or logical concept in GPT format. So whichever you want, you can use it in your working environment. You see still MBR is used, and few environments they are using GPTs also. So it doesn't matter which layout you use, the functionality of partition is same to store the data in a proper segregated way. Now let us try to talk about what is that zettabyte, zebibyte, or terabyte, tebibyte concepts of your hard disk. See guys, hard disk is measured in KB, MB, GB kind of thing. So let us try to talk on that, and let us see what is that zettabyte or zebibyte. See, normally if you see 1024 KB is equals to how much? It is 1 MB, right? Let me use capital letters for better understanding, right? Same way, 1024 MB is equals to how much? 1 GB. Same way, 1024 GB is how much? 1 TB. 1024 TB is equals to how much? 1 petabyte, right? Same way, 1024 petabyte is equals to how much? 1 exabyte, right? And 1024 exabyte is equals to 1 zettabyte. So that is the calculation of zettabyte. But nowadays, guys, this 2424 that is coming over here, 1024 KB, 1024 MB, 1024 GB. So this 24 calculation is little confusing. To keep it simple, right? The new units what are used now is mebibyte, gabibyte, tebibyte, pebibyte, xbbyte, and zebibytes, right? So how the calculation goes in that units, instead of using 1024, now we use flat figures, thousand, capital K, small I, capital B. It is represented like this, KIB. So 1000 KIB is how much? 1 MIB. Same way, 1000 MIB is equals to how much? 1 GIB. So it's a flat figure. That 2 4 value has been removed to make it flat and easy understandable by users. Right? So when you go now and purchase a hard disk, instead of GB, you might say GIB. Even when you purchase a RAM, instead of GB, it might be written GIB like that. So it's a flat figure. 1000 GIB is equals to how much? 1 PIB, right? And same way, 1000 PIB is equals to how much? 1 EIB XB byte, right? Same way, 1000, I'm sorry, 1000 EIB is equals to how much? 1 ZIB. So this is the calculation. So now when you do partitions and all in Linux environment from especially Red Hat 8 environments, you will find that the units are calculated in KIB, MIB, GIB, PIB, EIB. So whatever it might be, GPT will give you maximum hard disk size support up to 2 ZB or 2 ZIB, right? Or ZB byte, whatever you call it. So that is the unit conversion and calculation, that how a disk size is measured in KB, MB, GB, or KIB, MIB, GIB, whatever, KB byte, maybe byte, maybe byte, like that. So this is the partitions what you can create if you go with MBR and GPT. See, unfortunately, one thing what you might have seen, that when we do installation, during installation also we have done partitioning. But while we were doing partitions during installation, there was no choice it given to us. It never gave us a choice to select MBR or GPT style partitioning. During installation, automatically, depending on hard disk size, it chooses MBR or GPT. I think there should be a choice during installation that which style partitioning you want to make. But unfortunately, there is no such choice. When you go for partitioning, automatically it will decide that what type of partitioning it has to use. But whenever a new hard disk you add after installation, then you have a choice, right? The choice will be whether you are going to create a partition or not. What type of partition you want to make. Would you like to go with MBR style partitioning, or would you like to go with GPT style partitioning? So during installation, there is no choice. But after installation, when you go for partitioning on a fresh hard disk, then you will get a choice that you can go with MBR or GPT. I'll show that practically, that if a new hard disk you add, how you can choose partition table, either MBR or GPT. I hope guys so far the things are clear. Let's move ahead and let us try to understand one more very important criteria, that how you can identify that which type of disk you are using. Guys, when you go to a shop and when you purchase a hard disk, so when you ask the shopkeeper that I need a hard disk, they'll show you variety of hard disk, right? You might get IDE hard disk, SCSI hard disk, SATA hard disk, or SAS hard disks, or nowadays SSDs, which are very popular and faster, right? So different styles of hard disk will be displayed or shown to you. Each type will have better performance. IDE was little slow, SCSI came. SCSI was little slow, SATA came. SAS came, then SSD came, like that. So when you hold a hard disk in your hand, by reading it on the label, you will find out whether it is IDE or SCSI, SAS, SATA, which one. But when we are using it in a system, see, we would be somewhere, our system will be somewhere. Physically, most of the cases, we will never see that how our server looks like or what type of hard disks are attached inside it, kind of that. So in that scenario, how can I identify that what type of disk is being used? See, there are many commands with which you can find exactly what type of disk you are working with, right? But there are some hints that makes our life simple. So if you are using IDE type of disk, IDE is one of the oldest type of disk, right? I don't know how many of you are aware of it, but when we used to have Pentium 3, Pentium 4, right? Pentium 2, Pentium 3 processors, that kind of days, Pentium systems, then we used to get IDE. So IDE disk, and if I show you, right, it used to be something like this. IDE discs used to be like that. 34 pin, 40 pin used to be there. If any pin is tilted, it might not work. And a single belt used to get connected on motherboard, and it used to have two more connectors. One we used to connect to hard disk, and other we used to connect to CD drive. So olden days when we used to work with Pentium 2, Pentium 3, Pentium 4, in that times we used to have these types of disks. So obviously the performance of that disk was little slow, and that was okay for that era, right? So now it is outdated. We are not using it, but just for information purpose, I'm showing you that if IDE disk is being used, then you will find in slash dev all the disk's information are stored in slash dev. All the devices, in fact, are stored. If you recollect our architecture class, we discussed this, that all the devices informations are stored in slash dev. So in slash dev, the hard disk name will be HD, and this is the first hard disk you are adding, so the name will be HDA. If you're adding one more disk, the name will be slash dev HDB. If you're adding one more, the name will be slash dev HDC, then D, then E, then F, so on and so forth. The story would be continued, right? So disk's name will be A, B, C, D. HD will be common. First disk is A, second is B, third is C, so on and so forth. The story continues to go on. But if you do partitions inside it, then partitions will be slash dev HDA1, the first partition, then slash dev HDA2, then slash dev HDA3, and so on. The story would continue 4, 5, 6, 7, 8, 9, 10. How many partitions you have created, accordingly the names will be given. And second hard disk, if you do partitions, same story, HDB1, HDB2, HDB3, so on and so forth. Third hard disk, if you are making the partitions, same story, HDC1, then HTC2, then HTC3, so on the story would be going on. Hard disk names will be A, B, C, D, E, F, G, H, so on. Partitions will be 1, 2, 3, 4, 5, 6, so on, right? So this is how you can identify. If the name of your hard disk is displayed as HD something, that means it is an IDE disk that is connected to your system. But now guys, S letter technology is very popular. S letter technology means you might have SCSI. SCSI is pronounced as SCSI, right? And you may have serially attached SCSI, that is SAS, or you have SATA, or you might have SSDs. So any S letter technology, if you are using, the naming convention will be slash dev SD. First hard disk will be SDA, second hard disk will be SDB, third hard disk will be SDC, then D, then E, then F, so on the story would be continued, right? And if we do partitions inside it, the same story, SDA1, SDA2, SDA3, like that. And in the second, it would be STB1, STB2, STB3, so on and so forth. Same would be the case in third, STC1, STC2, and STC3, like that, right? So this is how the naming conventions would be given, and you have to identify that what kind of disk is attached to my system. And guys, nowadays, when we are working on cloud computing, so let us say that you have created a virtual machine on cloud, maybe on AWS or Google or Microsoft Azure. So inside it, sometimes you might see that the virtual machine created on cloud might show you the disk slash dev VDA or sometimes slash dev xvda. So what does this mean? This means that they are using virtual disks. Sometimes what happens, we use in the background either VMware, ESXi, right? Or you might do virtualization on Citrix. These are different methods, or what I can say tools that are used to perform virtualization. So inside it, the disks, whatever are created, might be displaying you the name as VDA or XVDA. So there is nothing to be worried about it, right? So these are nothing but virtualized disks or virtualized environment. The partitions would be VDA1, VDA2, or XVDA1, XVDA2, whatever it might be. But normally 99% either you might be going with HTA names or you might be seeing STA. In few environments, if VDA, XVDA you see, it is nothing but the virtual disks that are being created by virtualization software, right? Fine. And also there is a naming convention given for CD and DVD-ROM. So if you are using CD or DVD drive, you might see the naming convention will be slash dev SR. First CD-ROM will be SR0. If you have two CD-ROMs, SR1. Normally we may have only one CD-ROM connected, CD drive connected, I'm sorry. So single CD drive name would be dev SR0, SR1, or sometimes you might see the name dev SCD0 or SCD1, like that. So these are the names that are dedicated for your DVD or CD-ROM. And by seeing this, you can identify that what type of disk is connected to our system. Now, not to worry on this particular ground, guys. With a command, you can get more and more detail about the disk, including the model, type, serial number, all vital information about the disk can be collected. This is just an important hint to identify or to have an idea that what kind of disk is connected to your system. Moreover, with running few commands, we can find out exactly more details about each hard disk, which we will see once we start doing practicals, right? Fine. So let's move ahead.
So, I have a hello, sir.
Yes,
Can I ask you a question? Or
yes, Hamza.
so when it comes to the in S letter,
What is?
no, which one? How should we know? Is it SAS or in
Yeah,
SATA?
that's what Hamza I told you that when we start doing practicals, I'll show you a command with which exactly you will find out is it SAS or SATA or SSD, right? So let me show you that when we start doing practicals. Just a few more moments you need to wait for it. Okay, I'll show you. There are certain commands that allows you to get more detail about your disks. Okay, now moving ahead, the next thing what we need to deal with is something called file system. Now suppose guys, just imagine that you have a hard disk. In the hard disk, you created a partition. Now just by creating a partition, you cannot start putting the data inside it. After creating the partition, we normally format the partition. Generally, you might have heard this thing formatting. So what is this formatting and what it does? See, when you format a partition, it means you're freshly applying file system on the partition. Now, what is this file system? See, file system is a method of storing the data in an organized fashion on the disk. Every partition except extended. See, extended is a type of partition that is not formattable. In MBR, only extended partition is one that is not formattable. You can format primary partition, you can format logical, but on extended, even if you try, it is not going to work out. So anyway, every partition that can hold data must be formatted or given a file system. Otherwise, it would be very complicated to store the data and to retrieve the data. So you cannot properly store the data inside it. You cannot recover the data or retrieve the data inside it, right? So it is a method of storing the data in a perfect organized way so that reading and writing of data on the partition should be faster, and every partition must be having a file system applied through the concept of formatting. So normally formatting is nothing but applying file system on a partition. Now every operating system has its own file systems that are used. Like in Windows, we very commonly use NTFS file systems, right? Or previously we used to have FAT file system, FAT16, FAT32. Now latest is NTFS that is going on since a long time. Same way in Linux, especially in Red Hat, the native file systems that are used are EXTs and XFS, right? So EXT stands for Extended File System, and there are versions in Extended File System, Extended File System 2, Extended File System 3, Extended File System 4, or now we have XFS, that is Extends File System. The latest file systems that we are using in all Red Hat environments are XFS, which gives you better features. Now, when they was introduced, ext2 was released in 1993, ext3 was released in 2001, ext4 was released in 2008. But guys, XFS is not a new file system. XFS was introduced way back in 1993. But I don't know what went wrong that Red Hat was not that much curious to work with XFS previously. It was introduced by Red Hat and one more company called Silicon Graphic. So Silicon and Red Hat collaboratively created this file system in 1993, but they did not use it. They gave it for open source. Solaris used to use it a lot. But now they brought up some new features in XFS and they are now forcing us to use it. It is highly recommended by Red Hat that now in Red Hat 7 or 8, all the latest version, they are forcing us to use XFS file system to get better features, right? So what are the features that we get in XFS? Let us try to talk on that. See, first of all, if you see here, ext2 does not have journaling feature. ext3 support journaling feature, ext4 also support journaling feature, and XFS also support journaling feature. But the question here is, what exactly is this journaling feature? See, whenever it's this scenario might come in your working environment sometimes, or even in your day-to-day life when you are working with your laptops also. See, let us say that you are working on one file and in that file you are writing some data. Let us say you are writing a big information, or maybe you are a programmer, you are doing coding part. So you have written 10 lines, 20 lines, 100 lines, 200 lines, 500 lines. You are going on writing, 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 writing. But you did not save your work up till now. Suddenly, due to some issue, our laptop or desktop restarts. Suddenly, due to some problem, blue screen came, system restart, or light power gone, system restart, or maybe I was working over internet and I lost connectivity. Maybe my internet is down for 5 minutes and I lost my connectivity. So what would happen to the work I was working on? Don't you think my work is lost, right? So such data that is lost accidentally can be recovered back easily if your file system support journaling feature. Journaling actually stands for record keeping. So whenever you are working with a file and putting the data inside it, it records that data for you so that by mistake or due to any calamity, if you lose connectivity or system crash and you are not able to save your data, such data will be saved for you so that you can recover it back. So it's an important feature. Every modern file system now is having that feature, guys. Right? Journaling feature. So that feature you will get from ext3 till XFS. The next thing is maximum file size that can be created in ext2 is not more than 2 TB. Guys, there used to be ext file system, the first version, then ext2 came, ext3 came. So in ext version, the maximum file size was up to 16 GB, which is now scaled to ext2. That means one single file. I'm not talking about total capacity, I'm talking about capacity of one file. So in ext2 formatted partition, you can have a file with a maximum size up to 2 TB, one single file. Now same is carry forwarded in ext3. ext3 also has same file size capacity. Even in ext3 you can have a file with maximum size up to 2 TB, not more than that. But in ext4 this limit has been increased. So in ext4 you can have a file size up to 16 TB. That means one single file should be not more than 16 TB. See, 16 TB itself is a big size, and not in many cases you will see a file with a size up to 1 TB, 2 TB also, but scalability is provided always. Now in XFS, the new feature is you can have a file up to 8 exabyte or 8 XB byte. What is exabyte? We have seen 1024 petabyte is nothing but 1 exabyte, or 1000 uh, EIB, sorry, PIB is equals to 1 EIB, like that, right? Now, what is the total capacity? Like that, we can keep number of files and achieve in ext2, 3, 4, and XFS. Let us try to talk on that. So we just understood that one file size can be how much. Like that, how many files I can keep and what is the total capacity can be handled by ext2, 3, 4, and XFS. So an ext2 file system can support the size up to 32 TB. That means if your partition is up to 32 TB, you can put ext2 file system and you can work with that. ext2 can work maximum up to 32 TB size. If your size is more than 32 TB, the partition or the disk, whatever you are formatting, if that partition size is less than 32 TB, that means you can apply ext2. If your partition size is more than 32 TB, then you cannot go with ext2, you cannot even go with ext3. ext2, ext3 both supports maximum size up to 32 TB, but ext4 will give you more size. Maximum ext4 file system capacity is up to 1 exabyte or 1 xb byte. That means if you have a partition up to 1 exabyte or xb byte, then you can apply ext4 file system on the top of it. Total capacity of ext4 is up to 1 exabyte. Now, what is new in XFS? XFS will give you 16 times bigger capacity when compared to ext4. So XFS supports up to 16 exabyte size. So if your partition is up to 16 exabyte, you're thinking that your data might be that much, then you can format your partition with XFS. So it can support or hold the data up to 16 exabyte. Okay, now the last thing is moving from one version of file system to another. See, normally what happens, guys, that whenever we are working, new updates might come, like in your mobile phones also, you're working with one version of iOS or Android. Suddenly there will be new version available and you would like to upgrade it. See, upgrading should not lose your data. That is the important concept, right? So that was not possible till ext2. Previously, we used to have ext1 or just ext. So ext was not able to upgrade directly to ext2. That means you have to take the backup first of the partition, format the partition, all data will be erased, then you have to restore the data, then we used to go to ext2. So it is not called upgradation because when you upgrade, your personal data or whatever data present inside it must not be affected. So that concept came from ext3. So if you have ext or ext2 formatted partition, you want to upgrade it to ext3, you can easily convert or upgrade your partition from ext2 to ext3 without backup or restore. No backing up of your data or anything is required. Simply you can take the backup and simply you can upgrade. I'm sorry, no backup is required. Simply you can upgrade from ext2 to ext3. How it happens and all we will discuss in practical time, not to worry. ext2, ext3 both can be easily upgraded to ext4 without backup and restore. But same is not applicable in XFS. Why it is not applicable? Because in XFS there are no versions. We are still working with XFS first version. Maybe in future when we see XFS2, XFS3, so in that scenario we might upgrade. But ext2 to XFS or ext to XFS, it is not possible. Cross-platform upgradation is not formatted. See, you cannot upgrade Android with iOS, isn't it? Android is different, iOS is different. Same family, you can move from one version to other, but you cannot jump from one family to other family upgradation. That is migration that you need to do it by reformatting only. Taking backup, reformatting, you can go from ext to xfs, but directly from ext you cannot convert to xfs. And in xfs, as we don't have versions, so upgradation concept is not available so far when it comes to xfs. So these are the features of ext and XFS file systems. Now moving ahead, let us discuss one more important theoretical aspect. This must be very, very clear in your mind because here people might get confused easily. And I'm telling you that maybe today you might not perfectly get the idea of mounting, but when we do it practically, I'm quite sure that this concept will be crystal clear. So, what exactly is mounting and why we need to do this concept of mounting? See, mounting, let me tell you, is not a new thing that we are learning. Mounting is there in every operating system. Whether you are working with any flavor of Linux or Unix or even Windows. Every day we might do this activity, but the only problem is we don't know by name that this concept is called as mounting. So let us try to understand what exactly is the role of this mounting is, right? I need to draw something. Meanwhile, okay, I just logged in into the system. Let it keep logging. So the thing is, let us say, for example, you have a pen drive, right? We use pen drive every day a lot, isn't it? Now let us say this pen drive, I want to see how much data is there in the pen drive. Now guys, if I give you a pen drive in your hand, right? By holding a pen drive in your hand, by shaking it, can you tell me how much data is there in the pen drive? No, that does not work that way, isn't it? You cannot shake a pen drive and tell me these many files are there, these many directories are there, or this is the size, or this is the size used. You cannot say like that. You need to insert it into your computer, laptop, or desktop to view what is inside the pen drive, right? So when you insert a pen drive to your laptop or desktop, first of all, it is going to identify that what type of disk is connected to my computer. And as soon as it identify, it loads the driver, isn't it? And once the drivers are loaded, you will go to my computer. And in my computer, one icon appear. When you double click that icon, one folder gets open. Now this folder will display all the data that you have in the pen drive. Now guys, my question is exactly where is my data? Is it in that pen drive or is it in that folder? The obvious answer is it is definitely in the pen drive. But the problem is directly you cannot access your pen drive. You cannot see what is inside it. So we take help of that medium, that folder, which allows me to see what is inside a pen drive. So this medium, this method of attaching a drive to a folder is called as mounting. So mounting is nothing but attaching a drive to a folder in order to access the data inside it. Remember, directly you cannot access the pen drive. So we need to take help of the medium. For example,
I can't hear your voice. Maybe some other people are also not able to hear, so that's why they left. Can you please check?
Not audible, Sayed.
Okay, guys, can you hear me now? Everyone, is my voice audible?
Yeah, yes, I,
Okay.
Yes, sir.
Okay, guys. So, as I was telling you that mounting is a medium to access your drives which stores the data. Now, it can be your external hard disk, what you have connected, or it can be a pen drive, flash drive, what you are using, or the partitions inside your hard drive. Any readable, writable drive that can store the data, if you want to access it, you need to mount it. You need to connect it to some folder. Then only you are able to read it. And maybe once your work is over and you want to remove a drive, normally we does this a lot in Windows. Whenever your work is over and you want to remove that drive, we say safely remove the drive. You know, when you say safely remove drive, what exactly it does? When you say safely remove the drive, it breaks the connection between the drive and the folder, right? So this connection will be broken. And as the connection is broken, there is no reading writing activity going on. So it makes it safe for you to remove the drive, right? So this concept is called as unmounting. When a drive is connected to a folder, it allows you to read and write the data inside it. So we call it as mounting. And once you break the connection between the drive and the folder, it is called as unmounting. So remember this thing. Tomorrow I'll talk even more about this mounting and unmounting when we go practically working with that. So as of now, you just understand one thing in your mind, that without connecting a drive to a folder, you cannot see what is the data in the drive. You cannot make changes inside the data of the drive. If you want to make any changes in the drive, you need to mount it definitely. And once your work is over, if you don't want to use it anymore, then lastly you can do unmounting. Unmounting is like disconnecting the things, right? So that is the way mounting and unmounting will be working. Now this mounting is of two types: temporary mounting and permanently mounting. So what is that temporary and permanent mount? Let us understand that also. Let us say that I have created a partition SDA5. In my hard disk, I created a partition whose name is SDA5. Now to read and write the data in SDA5, I used one folder. For example, test. I have a directory test. So I connected SDA5 to test, for example. Now this mounting may or may not be permanent. See, if it is temporary mount, it will get automatically disconnected if the system is restart. So I connected SDA5 to test, and let us say we restarted the machine. And if you restart the machine and you see that the connection is lost, that means SDA5 is no more connected to test after reboot. That means it is a temporary mount. But if it is a permanent mount, it will be still mounted, still connected, even if your system is restarted. So permanent mount will not get disconnected even if the system is restarted. But if it is temporarily mount, as soon as you reboot your machine, automatically the connection between the drive and folder will get disconnected. Still, if it is not clear, nothing to worry. When we see practically, you'll understand the concept of temporary and permanent mounting very well. So as of now, just keep in your mind, to see the data in a partition or a drive, you need to connect it to some folder. This concept of connecting a drive to a folder is nothing but mounting. And when you break the connection between them, it is called as unmounting. So whenever a partition is connected to a folder, that connection will remain at least till the system is up and running. If you reboot your machine and the connection is lost, it is temporary mount. But even after reboot, if the connection stays back, that means it is permanently mounted. So how we can exactly know it is temporary or permanent, we will understand when we go with practicals. So as of now, I will just show you two simple commands to work with partitioning today. Nothing more than that. How I can identify that what disks are connected to my system and how many partitions are there inside it. To know that, the first command that we are going to talk about is fdisk. Fdisk is one of the oldest command that is used to deal with partitioning, right? So you can go with fdisk hyphen L command. So simply on any Linux machines, if you run the command fdisk hyphen L, now this is going to show you how many disks are connected to your system, what are those sizes, and how many partitions are there inside it. So you see the disk name it is telling you is dev SDA. So when there is a name SD, that means it can be SCSI or it can be SAS or it can be SATA, etc. And what is the size? 25 GB. I told you from Red Hat 7 and 8, instead of GB, the calculation used is GIB, 1000 format instead of 1024. And this SDA is so far divided into three partitions: SDA1, SDA2, and SDA3. And if you observe near SDA1, there is a star mark given. So what is the meaning of that star? See, that means this is your boot partition. Guys, during installation, we created three partitions: root, boot, and swap. I told you that boot partition is an important bootable partition that contains all your important bootable files. So if you want to fix your boot partition anytime, you should know that out of all, which one is your boot partition. So this star field represent that SDA1 is your boot partition. And you see it is giving you the size 1 GB for SDA1, SDA2 size is 15 GB, SDA3 is 4 GB, right? So like that, you can check the details. Now, what type of partitioning we have done over here? It says the type of partition is DOS based. So I told you MBR is also known as DOS based partitioning. So here it is showing you DOS. If it is GPT, simply it will tell that it is a GPT partition, right? Now, also it is telling you that this 25 GB or GIB is divided into how many sectors. Now, what is that sectors? Let us try to understand that also. See, when we talk about sectors, see, when you open your hard disk, let's say you have a hard disk, open the case of the hard disk. When you open the case of the hard disk, your hard disk will look like something like this. It would be just like your CD-ROM or DVD-ROM, round and round kind of thing. So each layer that is rounding up over here is called as cylinder. And each cylinder, data cylinder, is divided into tracks and sectors, right? So if you lose one cylinder, thousands of sectors are lost. And if thousands of sectors are lost, that means good usable space is lost. So what Linux does over here is it make sure that not only cylinders but sectors are not misused. So over here it is telling you that your hard disk is having total how many sectors, and you see here it is telling you that the partition is starting at what sector number and where it is ending, and total how many sectors are used by each partition. And observe over here that ending sector of one partition 199 it is showing you. Then the next partition is starting at a value 2099200, next sector, and it is going up till 33556479. And next partition is starting at 6480. It is going up till 5087. Then the next partition will start at 5088, like that. So with this mapping, you will be able to find out that your disk is using all the sectors properly or not for partitioning. See, few sectors here and there is not a big loss, but even if one cylinder is here and there, thousands of sectors will be lost. So previously, when we used to work with Red Hat 6 or lower version, in those times we used to manage cylinder. Like you see over here, it is written cylinder. Right? Previously, in olden times when we used to work with Red Hat 5, Red Hat 6. But thankfully, now what they have done, see, people used to miss one or two cylinders. And one or two cylinder using means you are losing a good valuable space. So from Red Hat 7 onwards, what they have done, they have converted that values of cylinders into sectors so that you can simply manage sectors. And one or two sectors or 10, 20 sectors also here and there is not a big loss. But losing one cylinder used to be a big loss. So you can actually keep track that where is the partition ending and next partition starting at what value. So like that you can make sure that not even single sector is wasted out. But still guys, there are few more questions in my mind which is not clear, right? I want to know exactly which technology of disk I am using. And if I am working with MBR, is this partitions primary, extended, or logical? I want to get that information also. So for that, you can go with our next command, parted-l. When we use parted-l, this clears all our doubt. So you see very clearly it is showing you the information that your disk what you are using is a SCSI based disk, or if you are using SAS, SATA, or if it is a LUN from SAN, all that thing it is going to show you over here that exactly what type of disk we are working with, right? And here also it is telling you that partition table is MS-DOS. And three partitions what are created are what? Primary partitions. If it is GPT, it is simply going to say partition. It is not going to say primary extended logical. We'll see that. We'll attach a new hard disk, we'll create GPT style partitionings, and we'll see that what type it is going to show you later on. But as of now, I want you to concentrate only on these two things, fdisk, parted. And I want you to do reading part. Either rewatch the whole recording one more time or read the manual what you have got, right? So those stuff should be very, very clear when we do practicals like creating partition, formatting, mounting. I'm sure mounting might not be that much clear, but tomorrow when we see practicals of mounting, I'll be very much sure that you will be definitely able to understand the concept of mounting very well, right? But remember, to read and write the data in the partition, it must be mounted. Without mounting, you are not allowed to access your drive and put the data inside it, right? So fdisk command and parted command are two commands that shows your storage devices and their partitioning details and other kind of thing. So that is it guys for today's session. We'll stop the class here. We'll not proceed from here. Now if you have any doubts so far, you can put your questions, guys.
Good morning, sir.
Yeah, good morning.
Sir, the lab software how to install in my lab.
See, I have shared a recording with you yesterday. Please watch that recording. Try to do it. If you have issues still, then let me know. But I want you to first try with yourself. Watch that video of installation. Try to do installation on your laptop. And if you face difficulties, then you can contact me. I'll try to help. No, there is no particular size GPT. It's a choice. See, when you go to some building, you might have stairs and lift. So it's your choice. You want to go with stairs or you want to go with lift. Same way, MBR and GPT is your requirement. If you see that the partitions 16 is not enough, you might be creating 20, 25, 30, then we go with GPT. If you think that 16 partitions are enough for you, then you can go with MBR. So there is no size requirement. It is requirement of partitions. According to that, you can choose MBR or GPT.
Performance will be different from MBR to GP.
Yes, Manoj, your voice is not clear. What's the question?
No, no. Any performance issues will occur if we are using either one.
No, nothing, nothing. It's only quantity.
Yeah, no.
MBR restrict till 16. But in an environment, 16 partitions are not sufficient. You want to go with 20, then you need to go with GPT. Performance would
Because
be same. Performance depends on which technology of disk you are using, right? That will give performance.
in general, in Windows, we are using MBR partitions only. So,
Right, right, right. Even in Linux also, most of the environment you see, we're still using MBR. But GPT is coming as a replacement for it. So having knowledge on that is also good because it gives more scalability.
recently, we also had a plan to replace with the GPT.
Hmm, right.
So in general, going forward, I think if we are using GPT, we can uh, it will be very useful for LVM. I think so.
Not even for LVM. Others, even MBR is also useful for LVM. No problem.
But
I told you na, limitation is important. How much limit you want to go, how many partitions you want to create, that is the only key to decide to go with MBR or GPT. LVM can be done even in MBR, LVM can be done in GPT also.
Hello, sir.
Yes,
Sir, go to meeting app also and you fix it to laptop also, sir.
it's your choice. Go to meeting, you can watch through uh, mobile phone or laptop. That is your choice.
Okay, sir.
One second. Okay, so I hope the questions are done. Anyway, tomorrow when we see practicals, more questions will be arising and more answers you will be getting related to all the partitioning concepts and all. So we'll stop the session here, guys. Let's meet up tomorrow and continue with practicals of partitioning. Thank you very much, guys. Have a nice day.